This is not going to be pretty, but I hope it works. 3 days of snow, here we go. What we're going to look at today is how to work problems involving concentrations. And there's a very definite format that I'm going to encourage you to use. I'm going to show you 2 different ways to work the problem. Both are logical, but I think one will help you as we move into the big 5 topics of AP Chemistry coming up. If you can develop these factor labeling skills, I think you can do anything. So, let's look at our equation for molality. Molality is defined as moles of solute per kilogram of solvent. This is very important that you are looking at the solvent and the mass of the solvent. Don't forget that. Well, we could expand this. If we were wanting to find moles, we know how we would calculate moles. We would take the mass of our substance and simply divide it by its molar mass. That would tell me the moles of solute. Remember that mass is in units of grams and molar mass is in units of grams per mole. So if you were to take mass and divide it by molar mass, you would come up with the number of moles of your solute, what you were dissolving. And then you would put that over kilograms of solvent. So I could simplify this to say mass divided by the molar mass of the solute, all divided by kilograms of solvent. You know, to me that is using an equation that you have to remember, and I think that there's a better way of getting to the answer through factor labeling. So we're going to look at 2 different ways of working the problem. And in every case, I'm going to encourage you to factor label, to use the approach that is being shown in red. Let's look at our first problem. In case you can't read it, since it's in a light green pen, it says, if I were going to make a solution of potassium nitrate, how many grams of potassium nitrate would I need if I wanted to make 750 grams of a 0.40 molal solution? Let's look at the first approach. I'm simply going to put all the numbers into the formula. 0.40 molal. I'm looking for how many grams of my solute will I need, X. I use the periodic table to find KNO3 has a molar mass of 101 grams per mole. And I want to make a total of 0.750 kilograms of solution. By doing the math, you should stop now and put it into your calculator to make sure you know how to get to this answer. I would get 30.3 grams of potassium nitrate is needed. I think there's a better way of solving this problem and a way that you will find helpful moving forward. Let's look in red. The number that I'm being given is that I have 750 grams or 0.750 kilograms of solution. So I can factor label. I know from this statement that for every kilogram I'm going to have 0.40 moles of KNO3. So my kilograms will cancel out, leaving me with moles of KNO3. I also know from the periodic table that 1 mole of potassium nitrate is 101 grams of potassium nitrate. All my units cancel. When I do the math, it gives me the same number. 30.3 grams of potassium nitrate are needed. Why would I like this approach? When you factor label, remember that the order in which you do your work, the order in which these three blocks are listed are not going to affect the answer. Let's try another problem. In the second problem, the question is going to be, what is the molar mass of an unknown solute? I'm going to make a 1.3 mol solution by taking 50 grams of this unknown solute and placing it in 250 milliliters of water. Two approaches. Here's the equation. I know the molality is 1.3 molal. I'm going to put 50 grams of some unknown solute into 0.250 kilograms of water. My answer, 154 grams per mole. Why is this important to you? Because we are always trying to identify an unknown substance. And here, by using concentration, we can solve for the mass of an unknown solute, and that will give us some clue as to the identity of the solute. A better way of working the problem, let's look. What if we were to take the information that we have 50 grams of our solute in 0.250 kilograms of water? Now, I'm wanting to get to the molar mass. Molar mass, big M, is in units of grams per mole. So look, I already have the grams here in the numerator. All I need to do is get moles of the unknown solute in my denominator. So I want to get rid of kilograms. That's something I know. And I want to go to moles in my denominator, so that by canceling out the kilograms, grams per mole are the units that I'm left with. Look at what we have here. We have a 1.3 molal solution. What does that say? It says that I have 1.3 moles in 1 kilogram of water. So this is moles of solute, kilograms of solvent. This is kilograms of solvent, that's canceled out. And this is my unknown solute here. So I'm left with units of grams per mole. And if you do this math, you're going to come up with the same answer. You're going to come up with 154 grams per mole. Okay, let's try one more problem. This last problem says, how many grams of water is added to 75 grams of glucose in order to make a 0.20 molal solution? Here's the equation. 75 grams. Glucose is C6H12O6, and you should know that. Using the periodic table, you would find that its molar mass is 180 grams per mole. I should have said grams per mole. And we want to find how much water has to be added to make a certain concentration of a solution. Well, the concentration is going to be 0.20 molal. So we only have one unknown. The unknown is here. Solving, we would come up with 2.083 kilograms, or that would be 2,083 grams of water would be added to make the solution. How would we factor label it? Again, the order of these is not going to matter. As long as your units cancel and you get to the unit you want to wind up with, you're fine. The order of these blocks is not important. I normally think of start with a number I'm given. And in this problem, I'm given 75 grams of glucose to make my solution. Let's start there. I can factor label from grams of glucose to moles of glucose by using the molar mass. Now I'm in moles of glucose and I want to get to my solvent. I would do that by going through, by using the concentration of 0.20 moles of glucose is present in 1 kilogram of water. And then, if I want to go all the way to grams, I would convert my kilograms of water to grams of water. Look at how the units cancel. Slow down. Pay attention to this. You could have started somewhere else, but as long as your units cancel, you get to the answer you need. That's going to be very helpful when we do equilibrium, acid-base, electro, and other advanced topics. So I'm going to go to Schoology and I'm going to assign you certain topics, certain questions at the end of the chapter. You'll find them there. And now we're going to start a second video.